we have an object that is rotating, as you see. And so we have a mass that is rotating in a vertical way. So this is all vertical. And by vertical, we have land, we have the sky is over here. And so hopefully you understand that a vertical motion is different from a horizontal motion in terms of how the forces are going to act. You have the force of gravity that is acting in this direction. So the speed of the ball or of the object at the bottom is 10 meters per second. The radius is 1 meter. We are asked to determine the tension in this instant. And so what is tension? Tension is the force acting on the rope. And what direction is tension? Well, tension will be pointing in this direction right over here. Because of course, if you measure, and you have to understand this, you have to differentiate between centripetal force, tension, and the force of gravity. Because these things may really make it hard for you to understand. Centripetal force is theoretical. Tension and force of gravity are real. These are the real deal. These are what are happening. And so there is a tension. If you measure and if you look, you will find that the rope has a force that's pulling it in this direction, upward. There's tension. And there's the force of gravity that is pulling this ball downwards. In every circumstance, F of G is always pointing downwards. So, the centripetal force is equal to the tension minus the force of gravity. The centripetal force equals the force towards the center minus the force away from the center. And that is why you have T minus F of G. So let's solve this out. We want tension. So we're going to have tension is equal to centripetal force plus F of G. The centripetal force is mv squared over r plus mg. And so mv squared, we understand that it's going to be 2 multiplied by 10 power 2 divided by 1 plus 2 times 10. That is the tension in the rope. And of course, it's a force. Tension is force, so it's going to be newtons. The second requirement of this problem is the hardest. Determine the minimum speed at the top of the loop. So the loop, this object is going to rotate in this fashion and in this direction. So at what speed must we achieve so that it does not fall, so that the loop is continuing? And so we're going to assume, and we're going to use a different color here, that the ball is up here. So it moved all the way to this direction. And so we have to find the minimum speed. So what's the minimum speed? Well, let's establish something. The tension is equal to 0. Okay, there's no tension here. As long as we have a minimum speed, there will be no tension at all acting on the rope. The force of gravity will act in this direction, and the tension, which is 0, is pointing in this direction as well. So the centripetal force equals tension plus the force of gravity. And so the centripetal force, what is the centripetal force? It's mv squared over r is equal to 0. The tension is 0 plus m times g. And we can remove the m's. And we have this very important rule that you better memorize. V squared divided by r is equal to g. which is acceleration. And since we're on Earth, that is going to be 10. So v squared divided by r is 10. The velocity, the minimum velocity, which is required, we know the radius is 1. So v squared equals 10. The velocity is equal to root 10 meters a second. And that is how we have solved the problem.